Hi, I'm Brayden Lexow. I attend Kansas State University and I am a junior in biological systems engineering. During my internship with the Pollution Prevention Institute, I was partnered with RedGuard out of Wichita, Kansas. So who is RedGuard? RedGuard is one of many brands underneath the Lane Company tree. They were founded in 1998 as a box for you. In 2005, there was an explosion at an oil refinery plant in Texas. This caused the government to search for better options to keep safety at these very hazardous locations. And a box for you began producing blast-resistant buildings. They then turned to change their name to RedGuard to better represent the products they now manufacture. So they currently manufacture mobile offices, blast-resistant buildings, and storage containers in the company's RedGuard, Sightbox, and Cover 6. So what RedGuard wanted? They had two main goals with their internship. The first one being RedGuard wanted to see all options for a solar generation system at their production center, PC, South Fabrication Center, FSC, and Portico Chase buildings, with interests in solar's financial and environmental benefits. The second goal for them was hazardous waste reduction projects. So RedGuard has recently turned from a small to a large quantity generator in hazardous waste. While this was mostly due to an inventory error, they would like to find ways to prevent this from happening again, as well as cutting down the generation of waste in their processes. Why, you might ask? So RedGuard is an ISO 9001 certificated company. This has to do with their quality management system, and part of keeping this ISO 9001 certification is to continually improve the quality management system, which can be done through pollution prevention and increasing efficiency as well as decreasing waste. They also want to appeal to environmentally conscious customers as well as return to their low quantity generator status. And as the RedGuard leadership team stated to me, they're looking to do the right thing for their customers, for their community, for their company. And I think that pollution prevention is a great way to cover all three. So a little bit about their process. While they have some upstream processes in sales and downstream in the delivery to their customer, I zeroed in on the manufacturing process of their structures. This starts in the South Fabrication Center. At the South Fabrication Center, they will take raw materials and process them, whether cutting, bending, stamping. They will then frame the structures and then weld on sides and occasionally floors. This will then be sent to the production center where it will be blasted, flooring will be installed, it will be painted, and then the internal components will be added and installed, such as electrical, HVAC, and any other internal components that their customers request. From here, they will do final testing to ensure quality, and it will be delivered to the customer. So a little summary of my projects. I completed 6 projects during my time with RedGuard. This includes industrial painter training, paint mixing process improvement, solar power system installation, air and gas leak audit, poor power factor correction, and painting booth lighting exchange projects. The net annual savings that I found was $266,283, with the environmental benefits being 996.5 metric tons of CO2 equivalent in greenhouse gas reduction, 316.87 pounds of HAPs reduced, 4,443.2 pounds of VOCs reduced, and then hazardous material input reduction of 12,377 pounds, a hazardous waste reduction of 5,906 pounds, electrical conservation of 216,150 kilowatt hours, and then a conversion to renewable resources of 780,870 kilowatt hours. So my first projects revolved around their paint waste reduction. The goal of these was to lower hazardous waste generation, lower paint waste, increase process efficiency, and ensure product quality. The initial idea for these paint waste reduction projects was industrial painter training. So currently, RedGuard uses an in-house training where their most efficient and best painters will train any new oncoming employees. The idea for this is to have an outside source come in and help train their employees so that they have the opportunity for the entire painter team to have a common training and hone the skills of more experienced painters. It could also help identify common mistakes that are potential sources of rework, as well as training for in-house painter trainers, so that the current painters on their in-house team can become more proficient in training new hires. This can also help relieve the effects of the high turnover rate found in painters in the manufacturing industry. So the best option that I found was a 2-day training from the Iowa Waste Reduction Center. They're based out of the University of Northern Iowa, and they're a top-tier researcher of technique and training in spray painting techniques. So this 2-day training includes in-class, in-booth, as well as very high-tech virtual simulation spray training. Through various reports, as well as case studies, I found some very important information that I used for my calculations. This includes a 17% average increase in transfer efficiency from over 200 students in one report, a 43% decrease in rework causing mistakes from another training report, and then a case study which found a 3% painting time decrease in one of their manufacturing customers. So this project is recommended with a net annual savings of $48,920 and a capital cost of $4,750. The payback period being 35 days. Some of the benefits of this painter training, the environmental impacts are a reduction of air emissions of 165 pounds of hazardous air pollutants or HAPs, 1,172 pounds of volatile organic compounds or VOCs, as well as a wasted hazardous input material reduction of 6,471 pounds of overused paint. Other expected benefits include a higher customer satisfaction from better finish quality, increase in workers' health and safety from a decrease in hazardous material use and painter safety training, as well as identification of painting mistakes, which could reduce reworks. And then there's also increase in painter efficiency, which can reduce painting time. So the decrease in wasted hazardous material comes from an increase in transfer efficiency, which is the ratio of paint that actually lands on the product or gets dispersed elsewhere. And the reason that it is only wasted hazardous material and not hazardous waste is that material being dispersed elsewhere just doesn't classify as hazardous waste. So then the next project was a paint mixing process improvement, the goal of which is to decrease hazardous waste generation as well as paint waste and ensure paint mixing quality that could cause reworks and reduce cleanup solvent use. Currently, RedGuard utilizes a hand mixing process. In this, they have pre-portioned kits that they mix together with a hand mixer and then run through their pump spraying system. So some of the problems with their current process include that it relies on painters' experience in mixing the paint to ensure accuracy, as well as that it generates a large quantity of hazardous waste through partially used kits. Now you might ask, what are partially used kits? So these partial kits, they're caused by the short hardening time and the long drying time of the paint. And it comes from the fact that the complete kits must be mixed fully and cannot be partially mixed. So for example, if the painting team only needs 1 gallon of paint to finish a building, but the smallest kit they have is 3 gallons. 2 gallons of that paint will automatically become hazardous waste. To track this, I came up with a spreadsheet and gave it to the painting team for them to track their daily gallons of paint wasted through these partial kits. I also had them track the number of solvent flushes as well as the gallons per flush, just to get some base data for later calculations. So for the paint proportioning system, so initially I investigated improvements to the current hand mixing process, but I found no really good options. From here, I moved on and found that electric proportioning systems would be the best option for them. These would eliminate the waste from unused partial mixes and increase accuracy to plus or minus 1%. It would also require less solvent to clean the system. So here, this is the system that I proposed, and it's the ProMix 2KE system from Graco. I chose Graco because RedGuard already uses Graco products, as well as that they're one of the leading manufacturers of this spray equipment. So a little analysis and the benefits. So this project is recommended with an annual savings of $90,644 and a capital cost of $18,000. This brings the payback period to 73 days. Some other expected benefits of this would be increase in worker health and safety from the decrease in hazardous material use and hazardous waste generation, along with more accurate mixing that could potentially reduce reworks, and an increase in painter efficiency, which would decrease the amount of time needed for mixing. So some of the impacts environmentally would be air emission reduction of 151 pounds of hazardous air pollutants and 1,069 pounds of volatile organic chemicals or compounds. So here, the wasted hazardous input material is 5,906 pounds of wasted paint, and then the hazardous waste is also 5,906 pounds, since the paint that is being wasted is immediately turned into hazardous waste. The next project that I reviewed was a solar power installation project, which is one of RedGuard's main goals, to see any potential options along with their benefits for solar generation. To begin, I tracked a year's worth of energy data to get their historical data. Doing this, they had 4 buildings they wanted me to analyze: the Fabrication Center, Production Center, and Portico Chase building. And the Production Center had 2 meters where the other ones only had 1. With this, I found the yearly consumption, yearly adjusted cost, and adjusted cost per kilowatt hour. Next, I took a look at their demand. So this could be a very important factor when it comes to solar installations, because it could greatly reduce your demand costs. And to do this, I had a year's worth of demand data for all 3 buildings, which is in 15-minute increments. And from this, I found the monthly peaks, which is how it's billed by monthly peak. And then I made a graph that compared the peak to the hour to see if they align with peak solar generation times. And using that, you can decide whether or not solar generation would actually help lower the demand. So for the solar generation project, I analyzed the South Fabrication Center and Production Center separately from the Portico Chase location, and you'll see that on my next slide. Some factors in consideration of this analysis would be the investment tax credit, which is a government incentive that would cover 30% of the total cost of the project in tax credits, as well as that solar generation equipment has favorable depreciation savings in tax savings, as well as 2 very important terms, which are net metering and parallel generation. These are both ways that an energy company can compensate their customers for the electricity they produce through solar generation. And in short, net metering is a much more beneficial system than parallel generation, as you can see up above. I also took a look at battery systems for these. There's partial battery systems and a full battery. So a partial battery could be like 1 or 2 hours of storage that can help you shave some of that demand, where a full battery would be a full day or multiple days worth of storage that would let you run your building completely on solar power. And taking a look up at the top right corner, I contacted 2 solar vendors, King Solar out of Hutchinson, Kansas, and Cromwell Solar out of Lawrence, Kansas. The best system I found were 3 180 kilowatt systems that used the investment tax credit. These are net metering eligible systems with a payback period of 5.5 years and a total cost of $616,638. I also analyzed for the total profitable savings after 25 years. So this is because I followed a model given by Cromwell Solar, and that they included that. And the 25-year period is based off the fact that solar panels have a 25-year production warranty that guarantees a certain amount of electrical production in a linear curve that decreases. So that just gives you kind of an idea of the growth of the worth of your project over time. And then if you look to the left bottom corner, you'll see King Solar's proposal for the three 180 kilowatt systems, which is my recommended system. At the production center, you will have 360 kilowatts of paneling, and in the fabrication center, you'll have 180 kilowatts. So this system is recommended, and you'll see when we get to the Portico Chase system, I do not recommend this system, and we'll get into that in a second. But so sizing this building was very tricky. For the past year, this building has been under renovation, so it has not been occupied other than people renovating it. That means that in the future, when it's at full capacity, it'll have a lot larger electrical consumption, and that will change the sizing like wildly. But the system that was proposed by King Solar was at the max for the net metering system size. So that means that any size bigger than that will become less beneficial, and this is the most recommended system that I can find. Looking at a payback period is 10.28 or 14.83 years, depending on whether or not you use the ITC. Total cost of $362,722. That was for the 10.28 years, and a profitable saving after 25 years of $417,000. That was also for it. So I do not recommend this system because RedGuard's preferred payback period is between 2 and 5 years. This is much over where the three 180 kilowatt systems is at 5.5, which is very close. And with the long-term savings that you can find there, I just think it would be worthwhile. So the project status is recommended, but for the three 180 kilowatt systems, this has an air emission reduction of 756 metric tons of CO2 equivalent. And this is due to a transfer of energy source from traditional fossil fuel burning at like power plants to renewable resources. Other expected benefits would be a better public image due to the transfer to renewable energy, along with a potentially larger client base from the addition of environmentally conscious customers. You could also find an increase in community health from less air pollution caused by the conventional generation of electricity and burning fossil fuels. This also allows for lowering RedGuard's carbon footprint, which has global health and safety benefits from the lowering of greenhouse gas emissions that reduces global warming potential. My next project is the air and gas leak audit. This was previously completed by 2019 and 2023 interns at RedGuard, but they wanted to try the project again. It identifies needed repairs and also targets emissions from energy production at power plants, as previously stated. So to do this project, I used a UE system, ultrasonic leak detector, and its companion calculator app to find leaks in compressed air systems and welders at the South FC and BC locations. Of the 29 leaks I found, 26 had been fixed or are in the process. Though while I was there, I could not get the cost of these fixes, which you'll see in my next slide. If you look to the bottom left, you will see that this is a picture of the ultrasonic detector that I used. And in the screen, you might be able to make it out. What it does is it takes a decibel reading, and using the pressure of the system, this shows you the output of the leak. And if it's a gas leak, you can directly relate that to the cost, where if it's an air leak, you can calculate the cost of the energy to refill the air that's leaking out of that from a compressor. And then to the bottom right, this is the largest leak I found. There's a puncture and a connection hose to an argon bottle in one of their welders. Based on an 8-hour workday, 255 workdays a year, this would have a potential cost of $22,390. Upon immediately reporting this, they had fixed it the next day. So this project is recommended with net annual savings of $51,083. Capital cost not associable because I could not get a total cost, and that makes the payback period not associated. The environmental impacts So GHG emission reduction of 181.89 metric tons of CO2 equivalent and an energy conservation of 187,656 kilowatt hours. Some other expected benefits could include the increase in weld quality for machines that did contain a leak, and an increase in product safety from decreasing the chances of a poor weld quality from a leak. So the next couple of projects that I'll go over are just general energy conservation projects. They target emissions from energy production at power plants and demand reduction, but they are kind of seen to help support the solar generation project, as a reduction in energy consumption can help with sizing of the solar generation system. So first, we'll look at a poor power factor correction project. So the power factor is a component of electrical billing that is related to demand pricing. It represents the ratio of apparent power to actual power from a building. So what this does is it shows the draw required by your building for the demand. It is common for industrial sites to have poor power factors, and power factors below 90% usually get penalized, and below 80% are considered poor. The penalization increases at a rate as the PF decreases. So if you look in the bottom left, you'll see that one of RedGuard's meters, they had a power factor of 74, which is quite very poor. Upon finding this, I contacted an Evergy representative, and while talking to him, we realized that RedGuard is one of very, very few companies that do not currently pay for their poor power factor, or like are not charged for the poor power factor, but that could change at any time. So I ended the project once I learned RedGuard does not pay for the poor power factor, but I do believe this needs more research, because if they were to begin being charged for the poor power
Barry,
factor,
let me look at that one.
if they were to begin being charged for the poor power factor, it would increase their electrical cost by $10,000 to $15,000 a year.
I did send something. Jennifer Curry was on it though. Okay, cool.
If you're at the meeting, please, if you could please mute your microphones, that would be great. Thank you.
Okay, so some of the environmental impacts have to do with decreasing the potentially higher emissions from peak demand energy production. And that can be seen on this map to the right. So this is from the Government Accountability Office. Every dot is a location of what's called a peaker power plant. And so these power plants are only operated during peak demand seasons to help with additional load. And they traditionally burn only fossil fuels and often are located in low income areas. So it's just a little bit of an equality thing and just a better emission reduction, that if you can lower your demand, you lower the need for these peakers and can potentially help in both cases. My final project is the paint booth lighting exchange. So previously, different interns have worked with RedGuard to switch some of their buildings to LEDs, and I found that most of the buildings were switched. But while I was touring their production center in their paint booth, I found that much of it was lighted by fluorescent lighting, but there was a small percentage of it that was LED lighting. Upon further investigation, this is because RedGuard made an extension to their paint booth, and in that extension, they added LED lighting. So they wanted to know, what are the benefits if they switched those fluorescents to LEDs? So to do this, I compared the two types of bulbs that I found in the booth, which are Satco 32-watt fluorescent bulbs to Philips Core Pro 14-watt bulbs. These Philips Core Pro bulbs are type A LEDs, meaning that they directly fit into old fixtures and need no modifications, which helps with the switching process. So this project is recommended with a net annual savings of $2,093 and a capital cost of $2,190. So this makes the payback period a little over 1 year. But if you take into account that the hour rating of the LEDs is greater than that of the fluorescents, much greater, it's a larger long-term savings of the LED bulbs because they will have to be replaced less often. So environmental impacts of this project are an emission reduction of 48.7 metric tons of CO2 equivalent and an energy conservation of 28,494 kilowatt hours. Thank you. Are there any questions?
Thank you. Which, so if people online have a question, please add that to the chat, or I can give a call to everyone so you can unmute your mic as well.
Actually, it's a good job on looking at lots of different aspects of what's going on there at RedGuard. I guess one question that I'd have for you is, given the nature of the containers that are being painted, they're big, kind of relatively flat surfaces. Did you look at using any type of powder coating or other types of systems?
Yes, one of RedGuard's sister companies actually manufactures storm shelters, and they use a powder coating process. But with the size of RedGuard's buildings, they say that they cannot use the powder coating, as well as to meet the very strict requirements within this blast resistant building nature. They haven't really decided if they could use the powder coating for it or not.
They think that it won't last as much as.
Yeah, it's just considered a little bit lower quality compared to the paints they use.
Brayden, I can help with that question if you'd like.
Yeah, Jason, you can.
So most of our buildings go out on lease. And when they come back in, we touch up paint and repaint to send them back out for another lease. So it's not as easy to touch up powder coating as it is traditional paint.
Sure. Quick question. The paint waste that you're looking at, did you correlate that to the actual amount of product that was moving through? So you could say, based off the summer versus the fall versus the winter, different amount of material going through the facility, different, rates of waste generation. Did you look at that to kind of?
So how we calculated like paint waste so we did it just as like an average based off of the month of data that I did, and used that to kind of extrapolate out, though it could definitely change from month to month. We just don't have any of that data necessarily. It was even hard just collecting total paint used for the year, because we could only find new production and how much paint could possibly be used for that. But then when you look into, not only reworks, but like those touch-ups that they talk about, we don't know exactly how much is going through for all those. We just couldn't find the data.
And have you found a waste hauler to take the paint? They do take the waste.
Oh, excuse me?
The waste from the paint.
Yeah,
Who takes it?
they do have a company that comes and clears it out. I can't remember the name. It might be Clean Harbor.
But it is
Safety Clean.
Safety Clean.
a
Sorry.
safety clean.
Sorry.
Yeah. So, but nobody else buys it, right? The leftover paints or anything from them.
So like incinerated
Mhm.
kind of thing.
No, I do not believe so.
Could it even be donated to like it's the Habitat Resort or anything like that?
So I mean, possibly some unused paint that has been sent around. That's where some of that inventory error kind of came from. But some of that has been in the past donated before to different schools. I think they said Wichita State has like a tech school that they've donated some paint to before. But the used paint, I mean, as soon as it's been mixed, you have 30 minutes or so, and then it's for however long, maybe 45. I can't remember the exact amount, but not a very long life in the pot. Yes.
So what is the overall impact of your intern program impacted the B2 opportunities for the company? So what is the overall impact from your intern projects? How much the company benefited, like in terms of?
So like what they have implemented?
implemented and like new practices?
Okay, I mean, they, like I said, they did implement some of the air audit things while I was there. I had, many meetings with, different levels of, their management, while I was, doing some of these processes, especially like the painter training. I brought that to their attention and it got them thinking about, well, even if we don't have this company do it, what if we had a different company, like maybe one of our, providers help us with it? And I mean, those are a couple of impacts that I could see while I was there, but going forward, I'm not sure what other ones they may have taken out of it.
And one other question.
Yeah.
What was the most interesting thing that you took away from the experience?
Most interesting. I would have to say is just learning so much about solar. Because I did a lot of research on solar, like how they charge it, how they compensate for it, like the difference between government regulation and then like how energy companies use that. There's, me and Chris had many talks because there's a lot of confusion in there.
Yeah, I was learning too,
Yeah.
so it was a really great learning experience for me as well.
There's definitely a lot of redoing calculations, and trying to figure it out how to do it the right way. But I say that was very interesting.
I had
Online, yeah,
yeah, this is Kurt with the energy program. I had a quick question on the power factor. So we've done a few site visits recently where the business has had a low power factor and they are being charged for it. And I was just curious if Evergy provided any explanation as to why a company would or would not be charged for the low power factor.
I believe that when I talked to him, I only talked to him once about it. He said that it was somewhere along the lines of partially the classification, and I think partially because they had two meters at this building. I think they almost kind of like merged them together and like averaged it so that it was high enough or something like that, even though it was extremely low. I'm not exactly sure.
Okay.
100% how they did it. He just told me that they were not charged for it.
Gotcha. Thanks.